So my name is Yaron. Yes, it's kind of the last session of the day. I try to keep it interesting. If you want to move forward, that's great. If you want to just stop me and ask questions, that's great too. I'll try to kind of stay here and not be up there, but we'll see how that goes. And yes, I've been with Iguazio. Before that, talking about flying, I founded a drone company, and we did drone flight control based on AI, machine learning and AI and things like that. And recently I've joined Iguazio, where what we're doing is a platform that provides both machine learning and AI platform for enterprises to simplify the pipeline from production to from inception to production, and we'll talk a little bit about that in a few minutes here. So what we're going to talk about today is about the real time. We talked a little bit more before on the previous session about real time and data-driven applications, and how do we make them simple, fast, and reliable going forward. So one of the challenges that we have is that data has time to live, basically. If we're doing batch processing like we're used to, then most of the time the data is days old. And that's batch. It's good. It's much better than not having data at all, but it doesn't help me make real-time decisions. Okay? If I take any type of streaming and do some ETL and data cleansing on it and so on and so forth, just that batching alone becomes minutes. Then you can call it interactive at best, but what we really want is we want to have event-driven and real-time. When something happens, you want to have at the same time something that would react and take some sort of an action based on that. And we're all kind of in the cloud era, if you will, where we say, okay, now we're just going to send everything to the cloud for processing. But at the same time, the cloud has a lot of compute power, but it has transportation costs, it has latency costs and other things. And if we look at what's going on, what's coming in next, the amount of data that we have is just enormous. So we must push at least some of the processing into the edge. If you're looking at the automotive and autonomous cars, you're looking at tons amount of data in a very, very short period of time, just because you have so many sensors. If you're looking at IoT and manufacturing, again, the amount of data over there is just enormous. And we were just joking about that earlier, that you take today, you say, okay, storage is so cheap, I'll just take all the data and store it somewhere, and we'll deal with that later. But think about it. If you want to do action in real time, I have to sort through that data immediately. I can't just store it somewhere and batch it later or tonight or tomorrow night and take action about that. And gaming in actual AR is even worse. You want to have the results in the game. You don't even want to wait for that. That means that you have to push it to the edge. Furthermore, if you want to upload that data to the cloud, you need some serious bandwidth just if you want to do that. If you're just talking about 5G, that's not there yet, it only eliminates a portion of that bottleneck. It's not going to get you to send all that 25 gig from a car, and it's continuous. It's 25 gig an hour. I can't continuously upload that to the cloud for crunching. It's just not feasible. So the challenge is, how do I combine that real-time information on a large scale with some sort of a machine learning and AI that would be real-time and intelligent, make decision and take action? Okay? So, and furthermore, let's say that I can take a small subset of that data and say, I can build a model that would work on that, and even figure out, let's say that I could figure out exactly what I want to do. How do I operationalize it? How do I make sure that I take not just one car, but I take a fleet of just 5? I don't even talk about, thousands or millions. And how do I operationalize it? everything that we have today is slow and not really actionable. And how do I extract not just the initial vectors, but how do I continuously improve myself with real-time data that I have? And again, of course, how do I do any type of exceptions? Because the exceptions are going to happen. It's not a question of if, it's a question of when. Right? And again, I got to not just collect all the data, I got to deploy it back to the edges in order for them to take action. So how do I do that as well? That's kind of the challenges. So if I take today's approach, what's the traditional approach? I can have a batch layer that would go through some ETL, some change logs, and processing and then storing it in a data lake. The problem with that is that, it's too low, it's too slow, and it's not up to date. By the time I finish the batch processing, the data is already not relevant. We talked about real time and not minutes or days. And it's complex. I got to build all that. I got to have some glue logic in between all of those sections and so on and so forth. The second option that I have is real time. In real time, I could use any type of streaming services, like whether it is a Kinesis or Kafka stream or any other, or Spark streaming or of that sort. This is not built for that amount of data. It's built for a small set of data. Okay? It's very expensive. If you look at like the Kinesis cost or any other services that are streaming online, the cost of that is by order of magnitude bigger than any type of batch processing that I want to have. And it lacks the context of where that data is coming from, how do I relay that to the location and things like that. Those are things that are coming in not as a stream, but they're coming in as a batch on the side. I got to somehow marry both of them together. So part of what we have, or what we do, is a real-time pipeline that takes all that information into a real-time time series database and have that model that I could query, I could query the same data using SQL or non-SQL or time series or streaming, all from the same set of data, and hence I could use all the tools that are currently exist in the market on a larger set of data in real time. I could do portion of that in an on-prem in the car, for example, or in my organization, and I could do portion of that in the cloud. It's all exactly the same. They work the same, behave the same. So from a development perspective, I only develop once, and I could reuse that multiple times. Okay? So if we look again, another comparison here between the operationalization of what's the traditional way of dealing with sources versus a continuous analytics. Okay? So again, we kind of talked about some of them already, whether you're looking at a Kafka stream going into a Cassandra and then a ETL through Spark and Hadoop, or you can kind of marry all of them. And the way to do that, realistically, is you got to use serverless. And when I say that, it's basically breaking, again, it's not something new. It's breaking all the functions into microservices and deploy microservices in an elastic way that would be deployed wherever it makes sense. If there's something that needs a lot of, let's say, GPU processing, let's put it where I have a lot of GPUs. If I have something that is a lot more frequent but a lot quicker, then maybe I would do that at the edge. And we'll have some examples of what exactly I'm talking about in a minute here. And again, one example is we talked about cars. So if we look at all the statistics from a car, you go into a parallel, you're going into an event processing and enrichment. So you take all of that, all the sensors from the car, which are, again, that could be processed inside the car itself, along with the geodata and some external sources of where they are. combine that into a parallel enrichment, because at that point I could do multiple containers or multiple microservices running in parallel, and take that enriched event and just push that up to only when an event requires that, push that up to state changes in the cloud. So I can only work on information when I need it. I could still store the enormous amount of data and cleanse it even before I even start storing it, and take action only on state changes or stream changes and things like that, whatever the trigger may be in this case. And again, I could aggregate, I could send some of the location, like the map updates, that I could do on a regular basis whenever is needed. Okay. So we talked a little bit about that. So what do I need in order to be agile and to provide services in a way that would be microservices oriented and that would be both persistent, reliable, and repeatable between the edge and the cloud? So I need some sort of a storage environment that would be persistent, storage that would be both files, databases, and I want to access them in any type, in any way that I can. I don't care if that data was stored as SQL. If my query is key value, I want to be able to do that. And that's kind of, otherwise you're forcing the developers to conform into, let's say if we're talking about SQL, into a schema. Maybe the schema is going to change in a little bit. I'm going to have some new, I don't even know what they are today, but maybe the car would have some new information in a week, a month, or a year from now. I don't want to be bound into an existing schema, and I don't want to go back and change everything else. I want to be able to have that flexibility to change the schema on the fly. On top of that, I need some sort of a orchestration layer. That orchestration layer, excuse me, today we're using Kubernetes as the orchestration layer, and there's some things on top of that, like kubespray and things like that. But it could be attached to whatever we provide as the platform provider, or you can attach it to your own orchestration services. Kubernetes seems to be flexible and easy to use, and pretty much de facto standard in the industry. That's what we've chosen that. But it could be multitude of any container services that are there. On top of that, you have all your application, which are containerized. Therefore, they are limited to location. They are already predefined in terms of user interaction and user-based access and so on. And on top of that, you need to build your business logic, whatever that may be. But the key value from what you need to remember from this slide is actually this, is what you really want is from all those open sources and tools that you have, those are tools. You don't need to invest time in those tools. Today, all the CI/CD and DevOps, it's basically a beast that we keep on feeding. What we really want is we want to innovate on top of those tools, and we just want to consume them and assume that they're there. You're not, kind of rewriting the OS every time you need to run a computer at this point, right? We already got used to the fact that we just need to consume something the way it is. And we got to get to this level here. And unfortunately, the industry, we're not there yet. Okay? And part of the way to do that is serverless. So if we look at what you're doing, when you're writing code, 80% of the time you're using it to build a Docker container and creating the images, and then building the CI/CD pipeline and logging and understanding and some kind of dashboard on top of that and so on and so forth. Instead of that, if you have, you write your code on, now we'll talk about serverless, and different type of serverless applications like Lambda in AWS and others. You write your code, you pretty much ignore everything else that is all the pipeline around it, because you just say, I want to run this, and I want to run it on a specific trigger. That trigger might be your real-time Kinesis or Kafka or RabbitMQ stream, or it could be a time-based, or it can be an event-based that is, the sun is rising and so on and so forth. The specification of how the platform is deploying it and how are you using GPUs or CPUs should be pretty simple to configure and based on context, not based on some kind of expensive IT infrastructure that you need to worry about. Okay. If we're looking at that, some research from Google talking about machine learning. So in every project, we have to use, we have to define what our KPIs are. We have to collect the data. We have to build a model, and we have to deploy it. Those are kind of the big 4 or 5 things that we use. If we look at what, that's what the industry thought that we're going to use, right? So a little bit of time on defining, randomly little bit of time to collect, and almost no time to integrate and deploy. What do you think the actual result that were from that research? Okay. Most of the time is actually being spent on collecting the data, cleansing the data, and building the infrastructure. If you look at that, very, very little time actually goes for the actual model. Very, very little time goes for the definition of KPIs. Why? Because most of the time we already know what we want. We just need to figure out how to get it. And significant amount of time goes for integration as well. Right? You have the source if you want on the bottom there, and I think the slides are available. Okay? So that's kind of an interesting concept, and I'm going to leave it there for another second, just so, I don't know, if any data scientists around here or people that are dealing with, they've seen this, agree with that statement? There you go. Okay. Yeah. So, the first time I've seen it, it's like, that's very interesting. It's, you think that most of the time is actually being spent on the model, but, I guess we've progressed enough that we have models being built, and we just need to gather the information. And that's not even talking about like, okay, I got the information. Now I got to cleanse it. I got to clean it. I got to give it to my data scientist in order for him to work on the model. And then when I get it back, oh, well, that doesn't fit the actual production data that comes in. I got to redo some of my ETLs again. So when you're talking about Nuclio is the code name, if you will, for our serverless framework, which is open source. So if you go to Nuclio.io, you can download and use it. And this is a serverless framework that actually is being built directly for machine learning application and big data. If we're talking about the traditional, well, I guess it's kind of an oxymoron to talk about serverless and traditional, but the AWS Lambda, for example, it's a way to reuse wasted resources. So it's being targeted as a singular, non-repeatable, or non-continuous workloads that are being spun up and spun down in the AWS cloud. Just to kind of counteract that, the unit of billing cycles is in 100 milliseconds. Right? So that just tells you I need to do something and then just let it die. So if I would have to build even an ETL function using a Lambda serverless function, I would probably need to have about 10 of those running sequentially, just in order to make it efficient. What we have is a serverless function that is more aimed and tuned towards machine learning. And then you have zero copy, which makes it a lot more efficient in the sense of data information. It's a lot faster, and it has built-in GPU support. On top of that, it's scalable in the sense that you can go and rebalance all across your existing cluster and you could trigger that pretty much from any source. Again, Kafka, Kinesis, RabbitMQ, just plain old timing and so on. And it is attached to a stateful database or data source of any kind. Okay? So you have a context when that function wakes up. Okay? And on top of that, it's open source. So if I choose whatever cloud provider that I choose, I would be attached to it pretty much forever if I attach all of my serverless function into that particular cloud environment. If I choose the serverless framework that I want to use, I could pretty much use it anywhere I want. So I could use, we talked about pushing it to the edge. I want to use the same functions. Maybe today I cannot use them in the cloud. I want to use them at the edge. Or maybe tomorrow I want to switch it, back or forth. I don't know. Why would I ever want to rewrite those functions? I want to have full control about where what is my infrastructure that I'm using, and I can move it from one location to another. And I can have it on-prem, I can run it as laptops for users, or I can use it in any cloud, basically. Okay. Just kind of going through several examples here. So the first one, and I think we've, it's kind of late in the show, and I think we've seen pretty much most of the use cases or the traditional use cases already. It's predictive maintenance. So if we have an IoT and we have a lot of devices and machines on the floor, they would continuously stream data, and that's where the real time comes in. They would go into a processor of a serverless processor that would say, okay, I got a real-time event that's kind of, alert somebody. But on top of that, I'm going to send it, I'm going to aggregate, reduce the number of outputs from that, and send it into a time series database, and going to store it somewhere on an intelligent edge. Once I do that, I could create a real-time dashboard that would be just the aggregation of that. I can feed it back into a machine learning function that would do some sort of prediction, and I could give you not just real-time alerts, but also predictions of what's going to happen next. And, sorry. We have some technical difficulties here. There you go. And on top of that, I can upload it to the cloud for safekeeping and data preservation and so on. The nice thing about this is once I upload it to the cloud and I save it there, I can also do some sort of triggering and have every now and then an update to my model. So I don't have to keep on looking at old historical data. Everything is already there. And from that, I can update my model and update the prediction and have some sort of a real-time feedback of what's going on going forward. Okay? So I'm not losing anything by the real-time alerts that are being set right now. I have my models that I know that are working, and I can do all sorts of predictive analytics going forward. Okay. Another example that we have here is network operations. Again, that's another pretty well talked about use case, is where I have a lot of network devices that are emitting all sorts of different types of information, starting from log files, going to SNMP, and so on and so forth. And those are just, again, we talked about the difference between SQL, non-SQL, and so on. Those would be different type of data coming in, flowing into a single location that I would like to do predictive analytics of both fraud I guess it's not fraud at this point, it's network security analysis and prediction of maintenance that would have like both historical and future correlation of what's going on. I got to have it as, that's got to be, again, a small footprint. I don't want to start sending all those terabytes of data to be processed in the cloud and then just collect the data and save it somewhere. I got to do some of that, at least at the edge. Okay, let's see if that one works now. That's a little bit of interactive. No, I guess not. Okay.
Of them.
Let's start that again.
Show me some cars.
There are 1383 drivers in Phoenix right now.
How many of them are busy at the moment?
412 of 1384 drivers are busy at the moment. That's 29% of them.
Can I see the list of drivers?
Here they are, starting with Ruby Naquin.
What about our income totals in the last week?
Looks like you made the most bank on Sunday, with around 18,600 bitcoins.
And how much on average did this cost each customer?
Here you go.
All right, that was just like a very short video. So that demo, here is the voice, or sorry, here's the what's going on behind that. So we have traffic data coming in from cars running around, in that case Phoenix, along with their Google Maps and location. It's all being sent into a serverless function to do what's called the ETL, save it into a Spark, and go through a Spark to save it into a database. And then that person that was talking on the radio, we're using network language services to kind of ask questions, get that voice query to be translated into something that the computer could understand, go through a Presto SQL query, and revert it back to both the UI information and voice output. Okay? All that demo was done in pretty much a very short time of probably a couple of days, just with collecting all the information and providing all that data. And again, talking about how do we collect the data, how do we bring the data, and how do we sort the data. The whole point of that was kind of, I have multiple sources, they're coming in from all different locations, and I could still do that in a relatively very simple, very short time. Okay, just to summarize that, what we really want is we need to have real-time, fresh data to work with. We want to use the data and innovate on what we do. We don't want to spend time on collecting the data. And we want to use things like serverless and newer functionality in order to give us breadth of information rather than just try to solve the same problem all over by integrating tools. And again, the amount of data is just enormous. So whether we want it or not, we would always have that conflicting information between pushing information into the cloud and doing the processing over there, or doing some pre-processing on the edge. And I don't think that's ever going to go away. It's just going to go in waves like everything else is going through. Any questions so far? Nope. All right. Thank you.
Thank you so much, Yaron. Please do not forget to rate the talk and give us your feedback. I have a small something for Yaron. I'm just going to quickly get it. All right.
Thank you.
A small something from us. Thank you.
Thank you very much.